Hi everybody. After the review session today, I wanted to go over question 10 on the practice midterm. And this question is on the Poisson distribution. And so the first thing I want to talk about is the fact that the Poisson distribution is a discrete distribution. And you will use the Poisson distribution if you have some type of interval and you have a discrete number of events happening in that interval. In this case, they tell you, well, shoppers enter Hamilton Place Mall at an average of 120 per hour. So your interval is the hour, and you know that 120 shoppers will enter the mall in that hour. So we know we're in the case of a Poisson distribution. And for Poisson, we have a parameter, and the parameter, according to your textbook, is given by mu. So, and Poisson has this nice property that the mean is equal to the variance is equal to the parameter. So if I have Poisson and my parameter is actually mu, then I know that my mu is equal to my mean is equal to the variance. And in this case, they actually told you what the average is. So they say there are 120 customers that will enter the mall in an hour. So we know that my mu in this case, so mu is equal to the mean is equal to the variance, and this is going to equal 120. Okay, so I know now that my mean is 120, that my mu is also equal to 120. Now, in the review homework of chapter 5, they have a list of the distributions with the mean of it, the variance of it, and you might want to print that out before you take the midterm. So for Poisson, we have that the probability that my random variable x is equal to some value of x. So the probability that x is equal to some value is given by my parameter mu to that power x multiplied by e to the power minus mu over x factorial. Okay, so this is the distribution for the Poisson random variable, and actually my x is discrete and it starts from 0, 1, 2, and it will continue like that. All right, so we know what we're working with right now. Okay, so we defined the random variable. The random variable is the number of shoppers entering the mall in a 1 hour period. The interval is very important for Poisson. The next question says, what is the probability that exactly 5 shoppers will enter the mall between noon and 1? So between noon and 1, that's exactly an hour. So we know that in an hour we have 120 on average. That was given. And we want to know exactly 5 shoppers. So all you're going to do is you are trying to test for 5. So we're going to look at the probability that x equals 5. And all you do now is we know what my mu is equal to. My mu is the average, that is the 120. So you can substitute for mu, you can substitute 120. I'm testing for 5 shoppers right now. So for x, I'm going to substitute 5 and e to the power, so this is multiplied by e to the power minus mu, which is minus 120, divided by 5 factorial. And remember, factorial 5 factorial is going to equal 5 times 4 times 3 times 2 times 1. And actually that is equal to 120 if you compute that. So it's going to be 120 divided by 120, so that will cancel with that, and then multiplied by e to the power minus 120. And if you work this out, you can just plug it into your calculator. It's going to give you a very, very small number, so it's almost 0. So that's the probability that exactly 5 shoppers will enter the mall. Question C asks, what is the probability that exactly 5 shoppers, so this was B. Now C asks, what's the probability that exactly 5 shoppers will enter the mall? So we're still testing for the probability that x is equal to 5. But now we're not looking at the whole hour. We're not looking at the whole interval. We're looking at only 5 minutes. So between 12:05 and 12. So from 12 to 12:05, what's the probability that exactly 5 shoppers will enter the mall? Now, that means we have 5 minutes out of 60. So 5 minutes out of 60. That's the fraction that we have of 120. In the whole hour, 60 out of 60 would give me 120. But now I have 5 out of 60 times 120. 60 goes into itself once, into 120 twice. So this is going to give you 10. So now my mu is not going to be 120, but 10. And so I just plug it into this formula here. That is my formula for Poisson. And it's going to be not 120, but 10 to the power 5 times e to the minus 10 over 5 factorial, which is 120. And if you compute that, it should give you 0.3, I'm sorry, 0.0378. Okay. Then question D asks you, and this is what we went over earlier in the classroom. Question D asks, what is the probability that at least 35 shoppers will enter the mall between 5 and 5:10 now? So now I'm not looking at 5 minutes or the whole hour. I'm looking at 10 minutes of the whole hour. So that is essentially 10 minutes out of the 60 minutes. And I know in 60 minutes I had 120, so I want to know what that fraction of 120 is going to be. And 60 goes into itself once, into 120 twice, and so 10 times 2 is going to equal 20. So this is going to be my mu now. That's my parameter. But now I want to know not exactly 35, but at least 35. At least 35 shoppers means the probability that x is greater than or equal to, the probability that x is greater than or equal to 35. That is what at least 35 means. Now, if you think about that, you'll have to compute the probability that x is 35 plus the probability that x is 36 plus the probability that x is 37, which is going to go up to infinity. So we can rewrite this as that equals 1 minus the probability that x is less than 35. And that's a little easier to compute because now we're looking at 1 minus, and the probability that x is less than 35, that's going to be the probability that x is 0 plus the probability that x is 1, 1 minus all of this, plus the probability that x is equal to 2, plus the probability that x is equal to 3, and you're gonna continue like that up to the probability that x is equal to 35, right? So up to the probability that x, I'm sorry, it's strictly less than 35, so x equals 34. That's important for a discrete random variable. So we have to look at all those probabilities. So we're really looking at 1 minus, and all of these are going to be the formula, which is up here. The formula is, I know my mu is going to be 20, right? And I'm going to have some x's, so 1 minus, my mu is 20, so it's going to be 20 to the power x. And then e to the mu to the power x, e to the minus mu. So e to the power times e to the power minus 20 over x factorial. And my x's will go from 0, 1 up to, sorry, this should be 34. Sorry about that. It's up to 34 because it's strictly less than 35. So it's going to go from 0 to 34. So I'm summing up, right, from x0, x equal to 0, up to 34. Now, when we did this in class, I said that if you get up to this stage, I will give you a perfect score. So you don't really have to compute this, but you have a button on your calculator to compute a sum from x equals 0 up to 34. So you can use that. I did it in Maple. So how you would do it in Maple or on your calculator, it would be the same thing, is you're just gonna type in, and let me redo this so I can show you. So in Maple you would do worksheet mode, and you would have 1 minus, and then you just click on the sum, and you will do the same thing on your calculator. Just click on the sigma notation. I now is going to become, we can just keep it I, so my x is now I. So this is going to be 20 to the power I, because I'm using I in Maple. So it's going to be I factorial and 20 to the power I. So 20 to the power I, 20 to the power I multiplied by e to the minus 20. E is over here, so that's just your exponential function. E to the power minus I